Hi, my name is Anshu and welcome to my channel Bottleneck. This is a data structures and algorithms series. In this series, we will be implementing algorithms and data structures using Scala functional programming approach. All the code related to our development can be found in the description as a link to my GitHub repository. This video is part 2 for the TIM sort. In part 1, we had understood what is TIM sort and we had seen an example of how TIM sort works. Here we are going to implement first part of the TIM sort, that is insertion sort. So as we know that TIM sort has one component as insertion sort and another component is where it merges the value. So let's implement the insertion sort first. So as we know, for TIM sort we will have something called minimum run length, which will be basically a value that we understood as 3. We assumed as 3. So the reason for having it 3 is just for the demonstration purpose. So for when your array size is less than equal to minimum run length, it will not be further divided and insertion sort will be applied on top of it. So let's implement insertion sort of type V, where input is going to be a sequence of type V. Let's give it an implicit of type V. With ordered, we are adding a power of comparison to the insertion sort. So now as we see in insertion sort, we will have two methods. One is for insert, another is for sort. So let's implement them. So insert will take a value of type V and a sequence. So let's mark it as BS, sequence of V, and an accumulator. So now we will have this accumulator initially as nil. Now we will do a pattern match on BS. First case, if it is not nil, if it is head and tail, if A is greater than head, then it's going to insert A comma T comma ACC, and here it's going to be head. Okay, next part is if anything else is there, then it's going to insert A. It's going to return ACC comma A plus BB. So basically if the value is BS, sorry, if the value is less than the value that we have found, so our A is less than the head, then eventually it's going to append or insert at the position, the order in which it is expected to be. So this is how insert will work. Next is sort. So in sort, again we are going to use one value as sequence of V, another would be ACC. It is going to be again sequence of V, and it is going to return a sequence of V. So how it is going to work? It's AS, and we do a pattern match. If it is case nil, it's going to return ACC. If it is anything other than that, say if has a value Then it is going to call sort on top of t, comma insert, and it is going to insert head. So it is going to sort itself. So it is going to be ACC. So this way it is going to check for each value and insert in the correct order or the position. So this is how our insertion sort will look like. And if I have to, so now here I have to call this sort with the value of sequence. Okay, perfectly fine. So this is our insertion sort. If you have missed this video, I had implemented insertion sort in one of the previous videos, so I will be adding link to that video in this description so that you can refer back. Let's test this insertion sort quickly. Well, my sequence is going to be the sequence of values. Let's add these values straight, and let's print insertion sort my sequence. Alright, so now let's see whether our insertion sort is working perfectly fine. So if your minimum length or minimum run length is equal to the input value, so it is working perfectly fine. So now the logic is, if your minimum run length is equal to the length of this array, then it is going to be straight insertion sort. If not, it is going to divide and then implement insertion sort and then merge it back. So this was the implementation of insertion sort, which we will be using in our tim sort. In the next video we will be implementing the merge and will complete our insertions, this tim sort. So if you like this video, if you enjoyed this video, please like and subscribe, and do not forget to press on bell icon to catch on future updates. See you in the next video. Thank you.